Okay, we're going to do algebra functions. This is part one, combining the functions, which is add, subtract, multiply, divide. And we always want to keep in mind what our domain is. So here we have two functions. Both of these functions are linear. And because they're both linear, the domain for both of them is just your regular standard default domain of negative infinity to positive infinity. Okay, and so we're going to add to them, we're going to subtract them, multiply them, and divide them, and we will check out the domain of each when we're done. So here we go. Adding functions, you just add the two functions. So this would be f of x plus g of x. And so that would literally be 5x plus 4 plus x minus 8. And we can just combine the like terms here, and we have 6x minus 4. So that is our combined function, the two functions added together, and the domain of this one is negative infinity to positive infinity, because we took two linears, added them together, and got a different linear. The second part is the subtraction. Now, subtraction of functions is a little trickier, just because anytime you throw in subtraction, you have to worry about signs. So f minus g of x is the same as f of x minus g of x. And so because it's subtraction, I'm going to be a little more careful when I write subtract. I'm going to do subtract g of x. And so that's going to force a little more sign change, and so that gives me 5x plus 4 minus x plus 8. And again, if I just do my combine my like terms, I have 4x plus 12. So again, I take two linears, I subtract them, I get another linear. Domain is still not an issue here. Okay. Now the third one is multiply. We'll be multiplying these, and these are technically binomials. And so to multiply them, I'm going to do f of x times g of x, which would look like 5x plus 4 times x minus 8. And using my FOIL method, I'm going to have to multiply this. If you're not familiar with the FOIL method, you might want to look that up. But I'm going to use the FOIL method. And so I'm going to have 5x to the second minus 40x plus 4x minus 32. And so I'm going to combine my like terms, and I'm getting 5x to the second minus 36x minus 32. Now, this one, again, does not have any domain restrictions. It's no longer linear. I took these two linears and now have a quadratic. But my domain doesn't change. I'm still same. Any numbers will work. Okay, now the last one is the division, and this is where we have an issue with domain, because we're going to create a fraction here. There's actually no math to be done here. We won't actually do any division. 5x plus 4 over x minus 8 is the division of the two functions, f divided by g. And there's no division that can be done, so that's it so far as the algebra is concerned. But I do have a domain problem. Now I have to exclude 8 from my domain. So the domain, you must exclude 8. And so now my domain is going to have changed. It's going to be all numbers except 8. And And so on a number line, remember it would look like a hole here, and you would color in these parts. And if you remember what that looks like in interval notation, your domain is going to be negative infinity to 8, and then 8 to positive infinity, and don't forget your u. Okay, here we go. We're going to do example 2 and 3, and we are going to add these two functions f and g in example 2 and determine its domain. The first one, f, it has a domain issue. We have the square root of x minus 7, and we need to determine the domain of that function before we begin. So because it's a radical, we do x minus 7 is greater than or equal to 0, and add 7 to both sides, and we get x is greater than or equal to 7, and that's our domain. That's 7 to positive infinity, and that's for the f function. G, the domain for g, is the default because there are no restrictions on an x squared function. So the domain for g is just negative infinity to positive infinity, it's no issues. Okay, so now we're going to add these two functions. If I add them, well, there's not any algebra I can really do. Let's look at this. F of x plus g of x would just be the square root of x minus 7 plus 3x squared plus 5. And I can't do any of that math. There are no like terms. And so that is the function that is added. That is the new function. However, the domain of our new function is going to match the original domain of the f function, because the domain of this one is basically controlled by the domain of that radical. So the domain of this one is also going to be 7 to infinity. Now generally you can just take the more restrictive domain when you are combining functions. And that's a good rule of thumb. Doesn't work 100% of the time, but that would help you for this. Okay, example 3, same situation. We got two functions. We want to divide them this time, and the domain of each of these is negative infinity to positive infinity. These do not have any restrictions as they are written, but when we combine them, we will have a fraction. We will be doing f of x divided by g of x, and that's going to give me 6 minus x squared over x squared plus 2x minus 80. Now this one has a domain restriction because of the fact of the denominator. The denominator cannot be equal to 0. So we're going to solve this out for 0. If you remember how to factor, this one's not a problem. It's going to be a plus 10 and a minus 8 for my factor numbers. And so x cannot be equal to negative 10, nor can it be 8. And so my domain for my new function would be all numbers except for those two. And if you remember how we do our little number line, so we can get our interval notation correctly, we can do all these numbers here, but we can't do 10, and we can do all these numbers here, can't do 8, and all these numbers here. So I have three little sections. So my domain is going to be negative infinity to negative 10, then the middle section negative 10 to 8, and then the right-hand section would be 8 to positive infinity. And I'll put my little u's in here for symbolism's sake. So, just looking at everything quickly, f plus g of x is equal to this, and this is its domain. F divided by g of x is this, and this is its domain.